Today we're going over the review sheet. So today, tomorrow, we're going through the review sheet. Monday will be a makeup day. And then the test is next Tuesday, Wednesday. There. One of those 2 days. As a review? No. Because I think there are 63 questions on the review. So there's not going to be 63 questions on the test. I do not know. And I've looked at it a few times over the last few days. I just have not been paying attention to that. Questions. So we're going to look at 1 through 4 first. Find the indicated root. So our first one is the 4th root of 20,736. So, at this point here, we can plug the whole thing into the calculator. So we can plug 4th root of 20,736. Clear all that out. So 4 root. So the 4th root of 20,736 is 12. And since we took the even root, we applied an even root to both sides, we have to put a plus or minus. Because when we take the even root, we apply an even root to a number, we have to put the plus or minus. Number 2. This time we are taking the 9th root of 512. So on the calculator we can do 9 second root. 512 is 2. And since it's an odd root, we do not need the plus or minus. Questions on this here? We'll do the same thing with 3 and 4. So number 3, we're taking the 14th root of 16,384. Is 2. But again, since we took an even root, we would put plus or minus. And lastly, number 4, we're taking the 5th root of 1024. And the 5th root of 1024 is 4. Now again, since it's an odd root, we don't need the plus or minus. We can only put the plus or minus when we're taking an even root. We're applying an even root to a number. Questions on this here? So we go with 1 through 4. We're ready to look at 5 through 8. We can look at number 5, 8 to the negative 2/3 is 1/4. 1/4 to the negative 5/2 is 32. We can do 1/9 to the 3/2, which is 1/27. And lastly, we have 16 to the second to the negative 1/4. And this one here, I would type it in exactly as I see it. 16 to the second to the negative 1/4 is 1/4. Questions on this here? Let's put this last one also to the 1/2. Now, at a certain point, it won't let you keep typing fractions because it doesn't have room. So if I wanted to type to the 1/2 power, we could either say 1 divided by 2 or find this here is 1/4. I'm going to say 1/4 to the 1/2, which is 1/2. We can find what we can and then do it again. Either way works. So any questions on 5 through 8? We ready for 9 through 12? Number 9 is the 6th root of 97,423. 6th root of 97,423. 9.9566. We're just going 4 decimal places. We can do the same with 10. 8/16 to the 1/9. 2.1063. Number 11. 2 to the 4/5 is 1.7411. And lastly, 12, the 5th root of 8. Root of 8 to the 8th is 27.8576. Questions on 1 through 12? We good with 1 through 12? Yes. What's interesting with the last one is if I make one number change, instead of 5, let's say the 6th root, it's 16. So if we feel good with 1 through 12, we can start looking at the next part. How do we feel about 13 through 16? I mean, because 13, powers of powers multiply, which would give us 6 to the 3/4. So we wouldn't be able to type that one in because it would give it to us as a decimal. But 13 through 16 isn't on the test. Or 17 through 20. Nope. So let's look at 21 through 24. Which one of these do we want to look at? Yeah. All you gotta do is type these into the 30XS. Graphing calculator will give you a decimal. You have to have these as in rational form, not decimal form. Radical form. Any other questions on 21 through 24? Are we good with 21 through 24? Yes. 30XS. The graphing calculator will not work. It'll give you a decimal. is even 23. Square root of 7 over square root of 10 minus square root of 2. Square root of 70 plus square root of 14 over 8. We go with 21 through 24. For problems 25 through 30, simplify each expression. We remember doing these, yes? Y'all remember these? I hope not. 523. 5.23. These are from 5.23. I mean, you can look for them. We didn't cover it. We didn't do 523. Nope. We're going to move on to 32. F plus g of x, f minus g of x, f times g of x, and f divided by g of x. Now the first one we're going to do is f plus g of x. Now this is going to be f of x plus g of x. Now f of x for us is 4x to the 5/4. G of x is 2x to the 1/2. Questions on this so far? Now since we're adding, we can go on and drop the parentheses. We have this here. Now the next thing we need to do is combine like terms. Is x to the 5/4 the same as x to the 1/2? No. So are they like terms? That's it. So any other questions on addition? Question? Yeah. Because x to the 5/4 is really saying that we're taking the 4th root of x to the 5th. And we're adding to it 2 times the square root of x. The 4th root of x to the 5th and the square root of x are not like terms, so they don't add. F of x minus g of x. So we have 4x to the 5/4 minus 2x to the 1/2. Now our first term is just going to stay 4x to the 5/4. Well, we do have to apply that minus to every part of the second term. Well, that's just questions on how we got to this point here. Huh? Yep. Okay, now we need to combine like terms. Yes? Well, yes. And what are our like terms? Well, there aren't any. If there wasn't any for addition, there's not going to be any for subtraction. So f minus g of x is 4x to the 5th, 4x to the 5/4 minus 2x to the 1/2. Addition and subtraction is nice with these, yes? Multiplication. F times g of x is the same as f of x times g of x. Well, f of x is still 4x to the 5/4. G of x is 2x to the 1/2. We're ready to multiply. Yes? 4 times 2 is 8. X. When we multiply like bases, we add the exponents. So we're adding 5/4 and 1/2. Calculator can do this for us. 5/4 plus 1/2 is 5 times g of x would be 8x to the 7/4. Questions? We good with this so far? We ready for the last one? Because our last operation is f divided by g of x, which is f of x divided by g of x. Well, f of x is 4x 5/4. G of x is 2x to the 1/2. Divide our numbers first. 4 divided by 2 is 2. Now when we divide like bases, we do what with the exponents? Minus. Because when we multiply like bases, we add the exponents. So when we divide like bases, we subtract. So 5/4 minus 1/2. Fourth minus is 3/4. So the last one is 2x to the 3/4. Questions on 32? We feel good about 32. Yes? Which brings us to 33 and 34. Finding f plus g of 2, f minus g of 2, f times g of 2, and f divided by g of 2. There's nothing wrong with these problems, they just take way too much time. So I'm not going to make you guys do those on the test because they're just more of a time suck than they are anything else. 33 through 30, or not 33, 35 through 38. Which one of these do we want to look at? 36. G of f of x. With all these composite functions, we always work from the inside out. So the first thing we're going to look at is f of x. We're plugging x into f of x. Well, that's just going to give us 7x minus 2. Now we're going to take g of 7x minus 2, which means every x in g of x we're going to replace with 7x minus 2. So we're going to have negative 2 times 7x minus 2 plus 5. Now at this point here, we're going to distribute the negative 2. Negative 2 times 7x is negative 14x. Negative 2 times negative 2 is plus 4 plus 5. Combine like terms, we get negative 14x plus 9. Questions on this here? we will. We'll get to 41 here in a second. Are there any other questions on 35, 37, or 38 before we look at 41? We feel good about our composite functions? Yeah. 38. G of x. Now for this one here, we're going to work from the inside out. So we're going to start with plugging x into g of x. Well, g of x is negative 2x plus 5. So we plugged x into g of x. And we get g of negative 2x plus 5. Now, we're going to take g of negative 2x plus 5. So every x in g of x is going to be replaced with negative 2x plus 5. So we'll have negative 2 times negative 2x plus 5 plus 5. Now at this point here, we're going to distribute the negative 2. Negative 2 times negative 2x is 4x. Negative 2 times 5 is negative 10 plus 5. Negative 10 plus 5 is negative 5. So we get 4x minus 5. Questions on this here? Any other questions on 35 through 38? We good with these here? We ready to look at 41? Yes? If you need, and you probably will, a little more space for 41, you can write it over where 33 and 34 are. Because I don't think you'll have enough room unless you go out to the side to fit that in. Now with these here, we always work for the inside out. So the first thing we're looking at is g of 3. So in every x in g of x, we're going to replace it with 3. Questions on this here? Now that we plug that in, we can simplify 2 times negative 3. Negative 2 times 3 plus 5. Negative 2 times 3 plus 5 is negative 1. So we plug the 3 into g of x, simplify. Now we have a g of f of negative 1. Now we're going to take f of negative 1. So we'll still have g, f, g. But now we're going to plug in negative 1 into every x in f of x. So we have 7 times negative 1 minus 2. So again, you can grab a calculator. 7 times negative 1 minus 2 is negative 9. Questions on anything we've done so far? I definitely need to put a lot more room for 41. Well, what do we do next? Well, now we do g of negative 9. Yep, so we're going to plug negative 9 into g of x, which is going to be negative 2 times negative 9 plus 5. Yep. It is. It is ending because we have g of f of 23, yes? But if you looked at where we started, g of f of g of f of g of 3, now we have, yes. Yeah. Mm-hmm. Yes. F of 23 is what? 7 times 23 minus 2. Now at this point here, we just need to take and find out what 7 times 23 minus 2 is. We can grab a calculator. 7 times 23 minus 2 is... We could just scroll down a little further. So now we're taking g of 159, yes? Which would be negative 2 times 159 plus 5. Have we gotten rid of all of our functions? So we're just taking it and plugging it into each one. But for the most part, you're plugging most of this in a calculator, letting it do the simplification for you. The most time-consuming part of this is just writing the thing than it is actually calculating it. Questions on 41. 39 and 40 are essentially the same thing, but instead of doing it 1, 2, 3, 4, 5 times, we only do it twice. Are you ready for 42 and 43? 42, we want to find the inverse. So the first step is to rewrite f of x as y. Step number 2, we need to switch x and y. X is equal to 7y minus 4. And now we need to get y by itself, solve for y. And the first thing we can do to solve for y is add 4. Telling us that 7y is equal to x plus 4. And we can divide both sides by 7, telling us y is equal to x plus 4 over 7. And then we can rewrite y as f inverse of x. Question on 42. Are you ready for 43? Yes. So what's the first thing we need to do to find the inverse for 43? We're going to rewrite g of x as y. So the next thing is we switch x and y. So x is equal to 2y cubed minus 7. And now we need to get y by itself. So the first thing we can do is add 7. Which tells us that 2y cubed is equal to x plus 7. And we can divide both sides by 2. Minus y cubed is equal to x plus 7 over 2. We take the cube root of both sides. It tells us y is equal to the cubed root of x plus 7 over 2. And then we rewrite this as what? Because we do g inverse because we started out this function as g of x, so its inverse is g inverse. Questions on this here? We're going to finish this tomorrow.